Another aspect of short-term memory that is a little different than long-term memory, of course, is our retention duration. Things don't last forever. And forgive me for reading these sentences. I just picked out what I think are the most germane sentences from the text. We regard short-term memory as the storage of information for short periods of time, but how short? There's an experiment that I've shown in the next clip in the folder, the Brown and Peterson experiment, that describes this retention duration and what can happen if memory rehearsal is quashed and you can't rehearse. In that case, it's actually difficult to recall even 3-letter trigrams. So the Brown-Peterson task is like this. They're presented with 3 consonant trigrams. They're also given a number such as 3, 4, 7 and asked to count backwards out loud. In the task that I've done, they're just asked to classify an even number. You'll see it when you look at it. It just lasts about 3 minutes. So the purpose of the interfering task is to prevent people from rehearsing the trigram, and the length of time that a participant must count or select an even number varies for 3 or 7 or 18 seconds. It takes a long time, and the longer that is, the less likely a person is to recall the 3 letters. Now you're probably thinking, my gosh, it's only 3 letters, but it's amazing if you're sent off to do another task, how much it'll get in the way of rehearsing those 3 letters and make us make a mistake. And we've all been through things like that where you've just got to memorize something very brief, like a phone number or a website address, and then something gets in the way, demands your attention, and you can't remember what you had to commit to. So, and your text lists that. So that's a decay explanation. So I'm sent off to do something else. I can't process it because I've had my memory rehearsal strategy squashed. So one theory is that the information that's not rehearsed decays or breaks apart within a few seconds, maybe 20 seconds. So if I tell you my phone number and you fail to do something to remember it, it'll just disappear after a short period of time. It decays. Now, other psychologists have said, well, I'm not so sure it's decay. What about just interference? Now, interference is easy to relate to. So I think of my in-person classes. Right now I have an in-person stats class that seats 20. To tell you the truth, after a few weeks now, I'm straining to remember anybody that may have been in a previous semester, because those 20 people in those 20 seats have effectively replaced the other people. They've interfered with them in my mind's eye, if you will. And that's not a criticism of anybody's impression that they made. It's just unavoidable. It's just a matter of one thing interfering with another. So this interference idea works as follows. Some information replaces the other. It displaces it. So your author gives the idea of your text or your workplace desk being messy and things getting in the way. Now, there was a clever experiment from Waugh and Norman, again going back to the 60s. It's amazing how many of these iconic experiments are 50 and 60 and 70 years old sometimes. On all trials, participants were not good at recalling digits from early as from later in a number, implicating that interference rather than decay in information from short-term memory. So the way this worked is, and your author even says that it's a little complicated, there's a lengthy number that's 10 or 12 digits, and you're asked to go backwards in the memory and recall a digit that preceded another one. The details are not super important. But one of the things that was manipulated by Waugh and Norman was the duration between the numbers as they were repeated verbally in a row. So 1, 5, 9, 7, 6. And my job is to repeat the number that preceded or came after the 9, which would have been 5 or 7. Now, in some cases, those numbers were spit out quickly. And in some cases, they may have taken a few seconds between the numbers at 4 per second or 1 per second. So it could have gone quite quickly or fairly slowly. The duration that it took to spit the numbers out, to actually say those numbers, proved not to be very relevant. The more important thing was simply the number of numbers that interfered with the ones that came before. So that's the interference explanation. And it's maybe the more compelling because I know things that have gotten in my way of remembering something, and I didn't do a very good job of clinging on to a memory that came before. So again, the most obvious example for me is I do strain terribly to remember what student took a class in what semester, because there's a fresh group of people every semester, especially in statistics, which I actually very much enjoy teaching, as I do cognitive. So this idea, the question is, chicken or the egg, is it decay or is it interference, is badly posed because it rules out the possibility of both. So short-term memory loses information by more than one mechanism. Badly argued that some trace decay does occur in short-term memory. Other authors propose that decay does occur and is in fact essential to avoid catastrophic sorts of interference. In other words, some things have to fall away in order for me to take on new things. But these authors believe that when information must be updated frequently in memory, its current value decays to prevent interference with later values. So for instance, when speed limits change, it'd be better off for me to have the most recent speed limit in mind and get rid of the old one as a function of decay for adaptive reasons. But of course, among the things that we've learned, especially with that Brown-Peterson task, is without rehearsal, decay happens. It can't be avoided. Now, we'll have some differences on this with respect to long-term memory, where there's less of a conversation about decay and things tend to hold up longer.